In this video, we will learn about classes in C++. Classes are the building blocks of object-oriented programming. A class is the blueprint for an object. Classes can have variables and functions. We refer to the variables in a class as the class's attributes. Functions inside of a class are called methods. To create a class, we use the class keyword. For example, we can use the class keyword and create a class named example class. Notice the curly braces after the name of the class, inside of which will go the code for this class. Also notice that we had a semicolon after the closing curly brace. Inside of our class, we are going to use the public access modifier, which means that anything beneath it can be accessed by code outside of the class. Let's create an int attribute named integer field. After that, we will add another attribute to our class, a char variable named character field. Next, let's add a bool named boolean field to our class. We can also add a float named floating point field to our class. Now our example class contains 4 attributes, an int named integer field, a char named character field, a bool named boolean field, and a float named floating point field. Let's add some methods to our class. For example, we can create a void function named method1, and inside of there we will output the string method1 to the console. We will also create a method with a void return type named method2, and inside of here we will output the string method2 to the console. In this video, we will learn about working with objects in C++. We create an object from a class. Since we have our class named example class that we created in the last video, we can use this as a blueprint for creating objects using C++ code. The first step is to declare the object. To do this, we type the name of the class and then the name of the object. For example, let's create an object of type example class named obj. Since the attributes were marked as public in our class, we can set them here. We access the attributes and methods of an object using the dot operator. For example, let's assign the object's integer field a value of 15. Then we will set the character field to the character value a. Next, we will set the boolean field equal to true. After that, we will set the floating point field equal to a value of 3.5f. We can also call the methods of our class on the object. For example, let's call method1. Then we will call method2. When we run the code, notice that these methods were run, and the console shows the output messages method1 and method2 respectively. In this video, we will learn about inheritance in C++. Before we jump into what the concept of inheritance means in code, let's understand it with an example first. Inheritance is when one object is a type of another object. For example, there are different types of vehicles. Each vehicle is able to move at a certain speed. A car and a plane are 2 examples of vehicles that move at different speeds. When a car moves, it is driving. When a plane moves, it is flying. Let's use the object-oriented programming concept of inheritance to turn this basic conceptual example into code. First, we will create a class named vehicle. Inside of here, we will use the public access modifier. Let's create a function with a void return type named setSpeed, which will take in one parameter, an int s. Inside of this function, we will set the speed of our vehicle equal to s. Next, we will use the protected access modifier. Let's have a variable of type int named speed, and a function with a void return type named move. Inside of this function, we will output the message vehicle is moving to the console. Vehicle is going to be the base class for the car and plane classes that we create, meaning that both cars and planes will be vehicles. Let's create a class named car. To make a class inherit from another class, we put a colon, then the public keyword, and then the name of the base class, which is vehicle in this case. Inside of this class, we will create a public function with a void return type named move. Recall that our base vehicle class also has a function named move that has a void return type and doesn't take in any parameters. When a child class defines its own version of the base class's function, we call that overriding the function. So in this case, the car class overrides the vehicle class's move function. Inside of this function, we will output the message car is driving at a speed of, then the speed, and then a new line to the console. Next, we will create a class named plane, which extends the vehicle class. Inside of here, we will use the public access modifier and have a function with a void return type named move. Inside of this function, we will output the string plane is flying at a speed of, then the speed, and then a new line to the console. Next, we will go inside of C++'s main function. Let's create an object of type car named car. Then we will call the car's setSpeed function and pass in a value of 60. After that, we will call the car's move function. Next, we will create an object of type plane named plane. Let's set the speed of the plane to 100, and then call the move function. Let's ensure that we have a semicolon at the end of each class, like the plane class, which ends on line 29. When we run the code, notice that the messages car is driving at a speed of 60 and plane is flying at a speed of 100 were output to the console. I want to show you how you can call the base class's function. For example, let's go inside of the plane class's move function and remove the code that is currently present inside of there. Then we will type vehicle with a capital V, : and then make a call to the move function. This is telling the code to call the vehicle class's move function whenever the plane class's move function is called. When we run the code, notice that the phrase vehicle is moving was output to the console.